in our initial setup that we looked at, there was one group that's getting something and another group that's getting nothing. Or that's getting a very different thing. That would be a control group, right? That's the group that you compare to what your stimulus is doing. Now with the example we just had, the migrants from poor, rich, high, low educated, there's no control group really, right? So we can compare indeed whether a migrant from a poor country is preferred to a migrant from a rich country or the other way around. But we can't compare that to someone who didn't see anything about migration. Someone who we didn't even prime to think about migration in a certain way. But we might want to do that. Depends on the research question again. So sometimes you're just asking what's the effect of mentioning the country of origin, and then just comparing the countries of origin is fine. But sometimes you might also ask what's the effect of talking about migration and then about the country of origin and migration. You know, it's different things. Do you prime a certain, wasn't a good example, do you prime a certain participant to think about something or not? When it's about violent video games, should the other group play a non-violent video game? Which I think would be a good idea, because they're also doing something. You know, they're also playing even, so they get into a similar mood, but they're just not playing a violent game, but a different game. Control group. Or should they be doing nothing? Would that be a good control? That would mean that the others are engaging in a lot of activity and the others, they don't, which is also something that varies. So no, we're not going to. When we do this stuff with news videos, for instance, we would always make sure that the control group watches a documentary about animals, or, you know, something very unrelated, but they see something, they're watching something, they're engaged in watching something. That might also be a factor, though. That might factor into factorial design. So you could ask migrant from poor country, rich country, country of origin not mentioned. High educated, low educated, education not mentioned. But you see, we then again come from a 2x2 design, low and high, poor and rich, to a 3x3 design, low, high, none, poor, rich, none. The initial one was nice, 4 groups doable. The bigger one is 9 groups, which more than doubles in this case the number of groups you need. So consider whether you do need the control group or not, and what the meaning of the control group would mean in the framework of your research. Can we do another 5 minutes before we have a break? That's great. What do we do when we do an experiment? We ask questions, we do our background research, theorizing, come up with hypotheses. You would never see experiments without hypothesis, by the way. Never, ever. Test your hypothesis with an experiment. Is it all working? Is it all good? Something to then analyze data, report results, and so forth. The research question for an experiment should be specific and relate to measurable variables. You would see that whenever you read about an experiment, research questions tend to be much more specific and concise than with many other methods that people use. So what are the effects of X on Y? And sometimes you would specify the condition, the conditional set. Yeah? And then you would consider some of the important issues like what type of experiment, and we'll get into that after the break. I'm actually looking at how does my sampling into the participant group looks like. So what people do I use for my experiment? How can I ensure the randomization procedure? What does my questionnaire look like? And what does my stimulus material look like? And what's this initial context? So that's at this point, sampling. Yeah, we saw that picture 2 days ago already, right? With experiments, you are very commonly on the non-probability side of sampling, and would use some kind of convenient sample tree. And many, if not most of the people would do this. We come to one case later where we move to this side of the chart, but with any experiment, we have in 95% of the cases, if not more, on this side of the chart. And it's not a big deal, since that is very common in experimental research. It's very accepted also. You just need to argue at some point in discussing your results how much you think the processes, the micro-processes you observed in your experiment would maybe translate to bigger populations, or what the limits of it is. And that's what you always need to do when discussing the results, but that is usually accepted to draw on convenient side of samples. Randomization procedures, ideally, and at the standard in the vast majority of things that I'm reading, you use a true randomization procedure. So you have your group of 80 people or 320 people, and you know how many experimental groups you have, be it 4 or 8, and you find some random procedure to put people into those different groups. Yeah? And that should be the ideal case. So whatever you do, try to do that. Sometimes we cannot do that. Or we are interested in comparing certain people. So you might be interested in comparing statistics, which is still, I wouldn't really do this. This happens when sometimes we do experiments at schools, and then we would show movies to entire classes of pupils. Then you suddenly we have some sort of blocking built in, and you need many more classes and so on and so forth. Don't worry about these too much. Try pure randomization for things that you'll be doing. Questionnaire design, see lecture of day 3 of yesterday actually, because a lot of the things we just discussed yesterday would apply to the questionnaires in very similar ways here. Again, here as far as possible, draw established measures, adapt those. Very common, in experiments you don't measure a lot. In the simplest scenario, you don't measure anything, but your dependent variable. So in the very simple scenario, there's no pre-questionnaire. There's just 2 groups, one get something, the other doesn't get anything, and you measure with one item maybe your dependent measurement, your dependent variable, attitude towards migration, one variable. That could be the simplest setup. That's not very advisable to do actually. Since measurement is so important in experiments, maybe even more so than in other things, I would strongly advise you for publication purposes to measure your dependent variable with multiple items, to reduce measurement error, to make sure you cover all aspects of a concept that could be relevant, and so on and so forth. And my experience also is that publishing experimental research based on one item dependent variable measurement is a very hard thing to do, if not impossible. Stimulus material, treatments. We'll talk a bit more about that later. Also, internal and external validity of the stimulus material needs to be given. So, just manipulate what you're interested in manipulating. And don't manipulate anything else. So, let's wait for the examples. And make sure that whatever you're manipulating actually has some reflection in the real world. It doesn't make sense to look at anything here that's not occurring in reality. I think for most of the sort of sciences that we're interested in. Internal validity is usually more of a concern, however, if you get to reviews and all of these things. So external stimulus validity, again, how likely the treatments occur in the real world, and often you will provide anecdotal evidence for that or argue for that basically. Sometimes what we do in media effects research is that we have a content analysis. I talked to you do a content analysis, of things you're interested in, advertising and the role of males and females in alcohol advertising, for instance. That's something you could look at in content analysis, and those findings could then feed into your stimulus manipulation. So you would find that males are often associated with alcohol in a group of friends, while females would be associated with alcohol in a different setting, and that would be those two conditions that then you use in your experiment and test whether it matters for perceptions of whatever you're interested in. Product, buy.
Sorry, could you expand that? I actually didn't follow the last one.
Did you fall asleep? No.
So the example, so basically you place those participants in different contexts.
You want to make sure that whatever you're interested in looking at in terms of stimulus has actually some resemblance what's going on in the real world. So I just talked to a student last week who's interested in looking at negative product placement. So when products and movies are played, we all know positive product placement, I guess. You see things popping up in movies that are really advertising. But he's looking at negative product placement. And my first reaction was, does that happen? Do people pay for their cars being put in a movie and then being trashed or breaking down or whatever? Does a beer company pay for showing a beer in a movie and then people would be breaking up after drinking the beer? So he was saying, well, I'm actually doing a content analysis of movies to show the degree to which these things actually appear in movies. Yeah? And that's a great way to actually combine content analysis data, which we'll talk more about tomorrow, with experimental data. Great way to show that your experimental stimulus material has a great external validity. I'm actually saying, I think my first publication, 2003, was based on such a... I was a student, and in one seminar I did a content analysis on how EU enlargement was portrayed in the media, and in the next seminar I did an experiment taking two of these different characteristics and used an experimental design. Internal stimulus validity. Does the stimulus treatment do what we want it to do? Do people really perceive it in the way that we think they would perceive it, they should perceive it? Do people notice the difference between the Bulgarian and the German immigrant when we show them the movie clip? No, that's something to consider. And then ideally it shouldn't vary on any other aspect, so that violent immigrant, maybe violent immigrant, be he from that should, no matter whether he's from Eastern Europe or Africa, that should in both conditions be a man, and not in one condition be a woman and in the other a man, because then you're not sure whether it's about men and women, the differences you find. So you need to be very concise in terms of creating your stimulus material. You should check how people perceive the stimulus material in pilot studies, ideally. And for that, by the way, we very often use students or crowdflower samples, because that's very easy, and then that's fine. Manipulation checks. Ask people questions about how they perceive the things that vary. This is an experiment which we published last year, and we were interested in to what degree different types of newspaper coverage would affect people's support for military intervention in a long ongoing conflict and their donation behavior to help people in the conflict. And these are just two examples of these manipulations. So one very obviously changed the pictures, right? There's one picture with militants in the Central African Republic conflict, and then one picture with the refugee child, basically. That's one thing we vary. If you look more closely, this is different. helpless to crippling poverty and hunger, terrorizing with the threat of violent militants. We actually changed these here, right? So we were interested in whether the picture or the text actually mattered here. But a lot of the text is the same. This is the same paragraph, this is the same paragraph. You see the caption is the same, the headline is the same, and so on and so forth. We'll take a break here, which is very necessary, I think. And again, let's try to make it not too long. Maybe for people that have never seen an experiment or dealt with this kind of research, you know, but will again interrupt me whenever you think I need to explain something more thoroughly than I'm doing, please. Can someone please just press OK? Thanks so much. So, and I'm afraid it's going to get very technical now for the next 10 minutes or so. After that, we'll calm down a bit again. There's two issues that generally come up when we talk about experiments. And whenever I'm talking to students or colleagues and advise them on how to do an experiment, whenever I'm doing that, really, the first question is, how many people do I need? And there's little in terms of the correct answer, the true answer. There's a lot in terms of experience, and I mentioned the number 40 a couple of times today, and that's what we usually aim at, 35, 40, 45 people per group. That's really a rule of thumb thing. But there's also something we call power analysis, which allows you to get at that a bit more systematically. How many people do I need? We also cover this because increasingly for international journal publications we're being asked to supply power analysis. Why is that? Because we know, and we will see in a second, the more people you have, the more statistical power you have to detect significant effects. So if I'm doing an experiment with 1,000 people and I've got 500 people in this group and 500 people in this group, thanks so much, chances that I find significant differences between the groups are there anyway, just by the sheer size of the groups. And that's sometimes a criticism you would get. So, we do power analysis quickly, and then another concern people often have, especially when it comes to experiments, interestingly more so than with surveys, is do people actually tell me the truth? In this experimental situation, they come to a lab, it's all artificial, funny situation that we're not used to. Some more recent developments would make much more use of non-self-reported measures to get around it. So not using questionnaires with questions, but different types of measurements to look at people's reactions to stimulus material. Even in the social sciences we do that more often nowadays. And that's two issues I'd like to discuss over the next 10 to 15 minutes. Again, it's maybe a bit more technical, but we'll come to other things. Power analysis, of course, is very technical because we're basically dealing with statistics. There we go. Why do we do a power analysis? Again, it's required often by funding agencies. You write up, I'm going to do an experiment for the 4 experimental groups, and I need 400 people for that. Funding agency would tell me, why do you need 400 people? I think you can do this with 150. We're not going to give you the money for 400, but only for what you actually need. So tell me what you actually need. Yeah? So we're required to sometimes estimate the sample size. And that's what power analysis can do. It can detect the required sample size given an expected effect size. I'll come to that in a second. Or it can say something about the probability of finding a certain effect under sample size constraints. So, We often use it to estimate our ideal sample size. How many people do I need for my experiments? But you could also use it post-hoc. Again, the example of 500 people in each group, to say, well, if that's your sample size constraints, there's a high likelihood that you find an effect. Other reasons to do this is, for instance, also, if you can't get a sufficiently large sample, why bother to do the experiment? If you know that by all means you can only get 30 people for two groups, you have 15 in one group, 15 in the other group, it's probably not worthwhile doing the experiment, because you don't have enough statistical power to detect differences between those two groups. Power analysis allows us to make sure that we have looked hard enough to find the effect if it's actually there. Looked hard enough is looked at a sufficient amount of people to be sure that, you know, if the effect still isn't there when you've got 40 people in each group or 60 people in each group, you're getting into a situation where you can be fairly certain there is no effect. My hypothesis wasn't supported. You need 4 quantities to do the power analysis. These 4 quantities: sample size, effect size, significance level you're looking at, and the power. Don't be scared, this is not as complicated as it looks. So the significance level is these p-values that some of you might have heard of already. With these p-values, the significance level tells us something about finding an effect. The likelihood of finding an effect, and it's in terms just to avoid type 1 errors, that you find an effect that's not there, versus the other way around. Not that important. If you've got any 3 of these, you can actually estimate the 4th one, right? That's simple mathematics. Now the nice thing is that we've got these 2 in general. These, as we will see in a second, are given. So we need to add this in order to estimate this, or we need to add this in order to estimate this, in line with the 2 things that power analysis allows us to do. And when we do that, and we'll look at that in a second, we see, for instance, in this case, it's for a medium effect size, I believe. This gives you the power of your experiment depending on sample size. So the power of the experiment is very low, and if only got 10 people, it increases 20, 30, 40. You get decent power levels, but you also see that it doesn't make much sense to add more than 100 people to the experimental group, because you get diminishing returns, right? The difference between 100 and 200 is way less than the difference between 0 and 100. So the 4 quantities again. We usually have P. We want to observe effects that have a 95% likelihood to be true. P needs to be at least 0.05. And it's not a statistics class really, so we don't go much into what the p-value is. But P can be set for experimental research at 0.5 at least. That's a convention. You know, you can be more strict, maybe more loose in some situations, but conventionally P is 0.5. Power conventionally is set at 0.80. That means that 80% of the times we do the experiment, we will find the effect, which for us social scientists would be sufficient. Sounds a bit like only 4 out of 5, really? Yeah. I mean, we're dealing with human social subjects, a lot of other things, so we're happy if we find 4 out of 5. So these are given basically in set. And then, based on these, you can estimate the effect size. An estimate of effect size is the key to the power analysis. You need to determine the effect size if you want to then calculate the sample size, right? We've got 2 of the 3 quantities are set. We need to set the 3rd one now in order to estimate the 4th one. This effect size is a bit difficult to set really, because we don't know what size, how big the effect should be that we're expecting of it. Or at least we haven't really thought about that. From my experiment on, what did we talk about, on voting behavior or non-voting, wasted votes, and I showed different people different poll results and expect that they would be voting differently maybe. Do I expect that to be a strong effect or a small effect? I don't know. The only thing you can do is base your expectations about the effect size in prior studies and or on theoretical considerations and or on pilot studies. Yeah? The combination of this might give you at least a feel for whether your effect should be very strong that you're affected or very small. I mean, in the type of research I'm doing, media effects research, we usually expect very small effects only. We seldomly think that our effects are mind-blowingly strong. But there might be other cases. This effect size then depends a little bit on the types of statistics that you're using, and this is very technical. But effect sizes, small, medium, or large. You need a number that you can input into the formula, right? We've got two numbers already, we need a third number. We need a third estimate, a third quantity. So, for anything we often do with experiments, that is a mean comparison. We compare the means of two groups, we get to that at the very end. People talk about small effects, of a size of 0.2, of medium effect size of 0.5, and large effect size of 0.8. I think for experimental research this is, maybe kind of mean this could be another one. ANOVAs here, 0.10, 0.25, 0.40. So one thing is you need to figure out what type of effect size am I expecting? Small, medium, large, that's the easiest to do, and if you refer to Cohen 1988, and there's a lot of mathematics behind this, that is usually sufficient. Look at this table and then think, okay, I probably expect a medium-sized effect, and my analysis later on is going to be an analysis of variance. Okay, let's insert 0.25 into the formula. And then we've got three numbers already. We've got the p-value, 0.05, we've got the power, and 0.80, and we've got the effect size, 0.25 in this case. And then what you do